Welcome to part 2 of our engine building course. So since the last video I've completed all the piston rings, everything's checked out good, I'm happy with that. The block's been washed. We're going to wash the thing multiple times. The first wash really is just to get most of the machining grit and the machining oil off of all the surfaces, so when I make my measurements of the crank journals and so on, that they are going to be accurate. This is not the final wash before assembly. The engine will be completely stripped once all the measuring's done, and then we'll be washing it again, because the last thing you want is one tiny piece of grit from the machining work to be in that engine still. So all the galleries here have to be blasted out. We pull the plugs out the side of the block to make sure we can blast through everything, to make sure there's not a single piece of grit left in this engine. Because what we're about to do now is look at the bearings, and it only takes a small piece of grit to ruin a bearing, and it's a bad day. So the block's been cleaned for the first time round since the machining. The crank has also been cleaned, it's over here. It's also got a dusting of oil on it as well to ensure that it doesn't rust. So's the inside of the block, that's why it's a bit darker. The journals just come out of the wash, they're not covered in oil. And I'm just drying out the surfaces as well to make sure we measure them, that there will be an accurate measurement. So what we're looking to do is work out the clearances required to install our crankshaft. The crankshaft has journal bearings, so it sits on these 5 bearings here. The other side of these bearings are on the crank here. You can see them on the centre of the crank. And what we need to make sure we've got the right clearance between the bearing that we've inserted onto this surface here and the crankshaft. Now, oil pressure is fed from your oil pump along the oil galleries, and these little holes here is where the oil comes out into the bearing. This bearing needs to fill with oil, and enough oil to maintain pressure without draining out, but also enough oil to lubricate the bearing without contact. Once up to oil pressure, that crankshaft should never ever touch the bearing surface. So it's absolutely critical we get the gap right between the crankshaft and the bearing. Now, in order to do that, we need to measure the size of these and also make sure they're round perfectly. So we need to measure them in multiple dimensions to make sure we've got a round journal in the block. If we haven't, we will then need to send it back to the machine shop and have it line honed or line bored to make it correct. Again, also if the sizing's massively off, we've made it that anyway. So each of these caps for the mains has a specific home. They are normally numbered or marked in some way. You can see that was marked number 4, so you cannot mix them up. When you disassemble your engine, take note of exactly where they came from and ensure you put them back in the same position. Not only that, but also the same orientation. In this engine, you can tell because you've got the little notches here and in here, and you want to ensure in this particular engine that those notches align. If you simply put it the wrong way around, at the right cap, this is no longer a true circle, and you might find your crank will not turn, or we have some other issues. As for fasteners, these are the old fasteners. Now we're going to put this crank in probably multiple times. We're going to put it in to measure our clearances, we're going to put it in to measure our thrust play and so on, and I'll only put the new bolts in for our final assembly. Another note on fasteners, the torque settings in your manual will be very specific for the fastener you're using. If you switch to an aftermarket fastener, the torque settings will be completely different. For example, you can put studs in here from ARP. Do not use the factory torque settings, use the ARP torque settings. Another note about torque settings is they are lubricant dependent. So ARP will give you normally a torque setting for their moly. If you were to use engine oil, that's another torque setting. And again, your engine manufacturer might give you an engine oil torque setting or a dry torque setting. You need to check with your engine building guide as to what torque setting and what procedure you use to do these fasteners up. So if you need to lube your fasteners, lube them when you're doing this as well. If you don't. If you're using moly, use a moly torque setting. If you're using engine oil, use an engine oil torque setting, because it's not about the actual torque, it's about the bolt stretch. And depending how clean your threads are and how you lubricate your threads will depend on how easy the thread turns inside the hole and change the amount of stretch you'll get at that torque. And what matters here is stretch. So be very careful as to what fastener you're using, what lubrication you're using, and make sure it's the correct for your application. So the aim in this video is to work out our crank bearing clearances. Now, A crankshaft sits in the main block of the engine like so, and there was what was known as bearing caps. These are known as main caps because they hold the main bearings for the crankshaft in, and these are bolted down with some nice big stretch bolts, or studded and nutted, one or the other. The outside diameter of the block should be circular, and the crankshaft should be perfectly circular, but they don't sit and touch each other. What actually happens is you insert a bearing piece of material here, which ensures you've got the correct spacing between the crank and the block. In most cases, your bearing is your variable size, so if you need to make a difference between the crank and the block, say it's too large a gap, you want a thicker bearing. If it's too small a gap, you want a thinner bearing. And most manufacturers will offer several sizes of bearings, although weirdly in this case, Vauxhall don't. Why that is, I don't know. So first of all, we need to measure the block and the crank. We take the block size and the crank size, and that will tell us how much difference there is. I'm expecting to see about 4mm. Once we know the exact size, we then know to check what our bearing thicknesses are. If we take the gap minus our bearing thicknesses, this will leave us the clearance. Now, every engine's got slightly different clearances. Some engines run tighter, some engines run looser. You will need to check your engine specifications as to what range of tolerances are acceptable. Some higher power builds may decide to go for slightly looser bearings than the original factory spec. In a good guideline for most reasonable power engines is normally to take the measurement of the journal, in this case is around 60mm, and take that as divided by 1000, which will give you probably an aftermarket sort of high power build clearance on the crank of around 0.060. So I think the Vauxhall spec's slightly tighter than that from factory. I'll be happy anywhere between 040 and 050 to 060, but I'm trying to just see if we can get an even clearance across all the bearings. If we can't, then we need to address it, whether some machining work is needed or whether different bearings are needed. We'll have to cross that bridge when we come to it. But for now, let's go measure our block and measure our crank and calculate by hand our bearing clearances. After we've done that, I'm going to show you the plastic gauge method, which I like to use as a confirmation, but plastic gauge is not foolproof, and I'll explain why later in the video, why it's very easy to mess up plastic gauge and get a false reading. So let's go measure our block. So before we can measure our journal diameter, we need to bolt down our cap in the correct place, correct orientation to the full torque setting. Now, there's going to be a lot of winding these bolts in and out every time you do this. So you can use a power tool to do it, but you need to be very careful that you're doing it gently and not starting the threads of it. So start your threads by hand to make sure they're actually catching. Don't just jam your gun on it. You can use a gun only if you use the lightest touch to wind your bolt in gently. Don't use your gun to do them all the way up, because if something's not aligning properly, you could do some damage, which you don't want to do. So you can use it to save time pulling them in and out repeatedly, but only use them gently to go all the way in and all the way out, and then do it by hand to start and hand to finish. So you want to crack them off by hand, wind them out gently with your gun. When you want to put them in, start them by hand, wind them down as you start to feel some resistance with a light touch on the trigger, stop, and then finish by hand. It's very critical you don't just get tempted to use your gun and just jam them all the way down, because you might do some damage. So this bearing cap has multiple stages of torque. You torque them to spec, and then you use an angle gauge to finish them off. Now, we're doing them individually here right now to measure them one at a time, but also when you put your crank in for real, there is a tightening sequence. And the tightening sequence that most engines you'll find is kind of similar. It's normally some sort of spiralling out to spread the load out across the crank as you do it up. So not only do you need to follow your torque settings, be aware that maybe there'll be a tightening sequence when your crank actually goes in. At the minute though, we're just measuring one cap at a time. So we're just going to torque each individual cap one at a time, then put a dial bore gauge in to measure each cap. So we need to measure our journals, and to do this we need to work out what journal size we've got. Now, using a pair of calipers we can quickly just estimate the approximate size of these journals, and these are the main journals here. Now this shows at 58 millimeters, so we need to use a micrometer for this, which is in a suitable range of 50 to 75 out of my box here. So we've got our calibration source again to check our measurements, and we're bang on the 50 mark on our 50mm calibration source. So we now need to set up our bore gauge to measure our circle here and our circle here. So once we've got our sizing set up on our bore gauge, something suitable for this, bear in mind this will probably be slightly larger, probably around 60mm, because there's a bit of thickness to the bearing. We can set our bore gauge slightly larger than that, probably go for like 61, 62. We then take a measurement on here of how much to subtract from the calibration size, which if it's 62, if this measures 61.5 for example, we'll take off the half to get the final read of 61.5. So our dial bore gauge is calibrated to 62mm. We're just going to insert it in. We're playing with these tiny little journals, there we go. And we're just going to rock it back and forth like before, and we're just going to see where the needle lands. And we seem to be measuring somewhere about 0.05 off of 62. Maybe 0.04 off of it. And then we'll just do it at whole different angles. I'm looking for the same result just to make sure our journal's truly round. It's the exact same result there. Let's try it this way. And the exact same result there. So we're knocking 0.04 of a millimetre off of our 62. The next step's to measure our crankshaft. Now, you need to make sure you measure the right journal for the right part of the block. So the snout here sticks out of cylinder 1, and the large part at the bottom is where the flywheel connects at the other end, in this case cylinder 4. So using our micrometer, we want to measure the size of the journal here, just to make sure it's the right size we're expecting. Measure it again in more than one place to ensure that it's perfectly round. So if we measure here, we need to rock it back and forth until we get to the point where it starts to go a little bit stiff. Take our measurement, do the same on this side and note them down. So with the measurements we've made, we've taken the size of the block, the size of the crank, and we've determined there's a difference of 3.98. Our crankshaft is literally on the small size of the expected crank journal size. The allowable tolerance by the manufacturer says the clearance has to be between these two values. If we know what the outside diameter of the block is and the inside diameter on the crank is, we can work out what range our bearings must add up to. By measuring our bearings with a small caliper, we can work out the thickness of the bearing. If we take the thickness of the two bearings added together, it must fall within this range for our clearance to be correct. If it cannot fall in this range, we need to make an adjustment. Now, Vox are a bit odd because they only give you one size of bearing and quite a large range to work in. If that bearing isn't right, all you can do is polish the crank or hone out the block. You can't really just exchange the bearing for a slightly different size. Most other manufacturers normally have 3 to 6 different bearing sizes, sometimes colour-coded, sometimes numbered. And depending on the numbers you calculate here, will allow you to order slightly different thickness bearings to get the correct clearance that you want. So measure your two bearings. You may even be able to find that there's different size bearings slightly in this pack, and you're able to mix two bearings that match that specific journal the best to get the best balance of clearance across the entire block. However, you cannot mix up the ones on journal 3 because these also include a thrust bearing. So you're kind of stuck with what you get here. This is a bit of a pain from Vauxhall because you can't just order a slight different bearing. You're kind of stuck with the bearings you get, and you have to make adjustments to your block or your crank if you need to make an adjustment. So now we've determined what bearing we want, we've got the right bearing, we need to install it into the block. You need to install the first half of the bearing into the block, like so, and the second half of the bearing into the cap, making sure that the tabs sit in their correct location. And again, when putting the cap back on, ensure that you've got the orientation correct for your engine. On this engine, the tabs go together. So what we need to do now is wind this in and torque it to spec as before, and re-measure with our dial bore gauge to make sure this bearing, once crashed into size, gives us the correct clearance. With our bearing installed and torqued down, we now need to calibrate our dial bore gauge again to the slightly smaller size, probably going to be looking at 58 this time, and then inserting it the same way, taking a couple of measurements across different angles and averaging them to give us the final size of this bearing once installed. If we then take this measurement and subtract our crankshaft, we should get the exact clearance that we've ended up with. Right, all 5 bearings have been measured and all are within spec. So the next thing is to test fit our crankshaft. And what we want to do this is to lay our crankshaft gently onto the bearings. We're going to do this dry. The reason we do this dry is we're going to plastic gauge to double check our findings to make sure we haven't made an error. So by gently installing the crankshaft like so, we're going to install each bearing cap, torque them to spec, but with some plastic gauge on top. So this is a plastic gauge kit. You will find there's different colour plastic gauges for different ranges of measurements. In this engine build, we need the red plastic gauge kit. Now, inside the pack, you'll get several of these little strips. And the idea is you take a small piece of this strip and you lie it along the journal, and when you torque it down, it will crush and spread out. You can then compare the actual squished plastic gauge against this chart here, which will give you the approximate size once torqued down. Obviously, the tighter the spec is, the more it will spread out, and the looser the spec is, the less it will spread out. This is a good, easy way of double checking that you've measured things correctly and you have got what you think you have. Now, plastic gauge can be misleading if done incorrectly. It's very important that once you put the caps on and torque everything down, that A, it's dry, you haven't put oil in there, and also that you don't move anything. If you ever so slightly rotate the crank or try and torque things down, which for the main bearings isn't so much of an issue, when you are trying to torque the rods, however, it's very easy to nudge the crank and ruin your reading. So this is why plastic gauge is good to double check everything and good to confirm you're on the right track, but the other method we've showed you first of actually measuring your crank, measuring your block and everything is the preferred way to do things. But this is still a great test to do to confirm what you've measured is correct. So if you look very closely, you can just see the small strip is laid across the journal like so. And one on each of the main crank journals has now got plastic gauge on it. And we're just going to install all our caps, ensuring they're in the right position and right orientation, remembering to check that the bearing notches match up on the right point and each cap is in the right position and not mixed up. We're now going to torque them all down. Once they've torqued and settled, we're going to remove the caps again and see how much the plastic gauge is stretched out by. One more thing to add, when you're torquing down the caps with the crank installed, we are now going to use a torque tightening sequence. And you'll find again for most engines there is a sequence for caps and cylinder heads and so on. And it's usually a spiralling outward or spiralling inward or a crisscross pattern that you'll need to follow to ensure that you spread the load on the crank evenly across the crank as you do the bearings up. So once you've removed all your bearing caps after torquing them down, you will see that the plastic gauge has left a tiny mark on the journal of the crank showing you how much it's expanded by. Now, it's a bit faint on this crank, but you should be able to take your card and line it up against the markings like so and get an approximate reading of how much they've stretched out by. You'll also find that it's more likely that a lot of it's also end up on the bearing as well. So you may wish to use the measurement on the bearing instead. Once you've done your measurement and you're happy that the reading matches what you expect, try and clean as much plastic gauge off the crank and the bearings as you can. But be aware that if you do miss a tiny bit, it is actually oil soluble and it will dissolve in the oil once the oil goes around the engine. So don't worry about if you miss a tiny bit or you can't get a little bit off. I find one of the best ways to get it off is just to get your fingernail and lightly rub against it and it all will come off. Okay, thanks for watching. That's it for part 2. In the next video we will look at our crank's thrust bearing play, and we'll also look at the connecting rods, following a similar procedure we've just done with the crank bearings to measure our connecting rod bearings.